affecting this enzyme working pattern or their activity. So first, that is enzyme concentration, substrate concentration, and product concentration. Simply you are remembering that enzyme attach over the substrate and making product, and these three concentration of enzyme, substrate, and product that can affect enzyme activity. Next, that is pH and temperature. Both are the important physical particular factors that physics particular pH of the surrounding tissue and where the enzyme is working, and temperature of the surrounding tissue that is also affecting enzyme activity. Next, that is activation and inhibition as well as regulation of this enzyme. So many inhibitor molecule or activator molecule will be present in the surrounding tissue, and that can also affect enzyme activity. Next, that is induction and repression. Enzymes are basically protein in structure, and they are made up with the help of particular gene. So whether that gene is making more enzyme molecule or decrease enzyme production, that is called induction and repression. Further, covalent modification means that structure of enzyme is present, but it will be modified depending on the need of the cell. So whether it is adding of any other particular group that will modify, or covalent modification over the enzyme that can also affect enzyme activity. And lastly, that compartmentalization. So you have already seen that some enzyme are present in the cytoplasm, some enzyme present in the mitochondria, or some are present in a Golgi body. So these presence of these different enzyme over the different compartment, that is also important part of regulation of this particular enzyme activity. So all these factors are important for the enzyme activity. You have to remember enzyme, substrate, product, pH, temperature, activation, inhibition, and induction, repression, further covalent modification, and compartmentalization. So these 10 factors are the most important for the enzyme activity. We will look one by one that each factor. So first one, that is enzyme concentration. So rate of a reaction or velocity is directly proportionate to the enzyme concentration. Here condition is that substrate is sufficient and sufficiently present. So velocity of reaction is increased proportionately with the concentration of enzyme, provided substrate concentration is unlimited. Suppose that you have 10 enzyme molecule and you have 10 substrate molecules. So suppose that in a 1 minute enzyme is able to make substrate into the product. So within a 1 minute product will be generated. Now if you have an unlimited substrate concentration, initially you have only 10 enzyme molecules. So within 1 minute you will get 10 products. Suppose you have 100 enzyme molecules. So after 1 minute you will get 100 products. So if you are increasing enzyme concentration, more product will be generated. But here condition is that substrate should be unlimited. So this property is also useful in a clinical laboratory to determining the level of particular enzyme in the plasma, serum, or tissue. So that is importance of the enzyme concentration or factors affecting enzyme activity. Most important, that is enzyme concentration. Simply it is explained in this graph. If you are increasing enzyme concentration, reaction rate will also increase proportionately. Condition is that substrate should be unlimited. Further, next, that is another factor, that is substrate concentration. So as substrate concentration is increased, the velocity is also correspondingly increased in the initial phase. Here you have to understand that in the initial phase only, but the curves will be flattened afterwards. So at lower concentration of substrate, more enzyme molecule are remaining idle, and further as substrate is increased, more and more enzyme molecule are working. Suppose you have only 100 molecules of enzyme. Initially you are adding 10 substrate, then that within a 1 minute 10 product will be generated. You are adding 50 substrate, then 50 product will be generated after 1 minute. You are adding 100 substrate. So now when you are adding 100 substrate, what happen, all enzymes of 100 molecules of enzyme is attached over the substrate, and after 1 minute all product 100 product will be generated. But suppose that you are adding 150 substrate, then what happen, only 100 is now able to attach over the enzyme, but 50 substrate is now not able to attach over the enzyme. So that we will look in this graph or this animation, particular substrate and product. So substrate concentration over the x-axis, product formation over the y-axis, and this increasing substrate concentration gradually increase the rate of reaction that we will look in this graph. So particularly initially we have taken that 8 test tube, in all these enzyme and substrate is added, but gradually we have increasing the substrate concentration in this micromole. So after the particular fixed time period we are getting the product. So if you are adding more substrate, more product will be generated. But here condition is that where this enzyme concentration is increasing, but once there is a all enzymes molecule is attached, further reaction is not able to increase. So here over the graph, initially that substrate concentration is increasing, graph is steadily increasing, but after some time it will be flattened. So that flattening because of all enzymes molecular attach over the substrate. Now further not availability of any enzyme molecule to attach over the substrate. Further in detail that we will do. So basically enzyme activity is increased in the initial phase, all the enzyme is combined with the substrate, so that is concentration is increased initially, velocity is increased, but after some time it will be flattened. So that is importance of the substrate concentration. So at half maximal velocity what happen, 50% of enzyme are attached with the substrates. We have taken example of 100 enzyme, in that suppose you have added 50 substrate, so 50 enzyme molecule is attached over the 50 is substrate, but 50 enzyme is remain unattached with this enzyme. So the maximum velocity is obtained, that is called a Vmax. It represents the maximum reaction rate attainable in presence of excess substrate at substrate saturation level. So that is also important thing for getting of a one particular value, that is Km value, that we will look. So basically what happened, first that is reaction velocity initially increased and later on it will be flattened. So when it is flattened, that is called a Vmax, that is initial velocity, and after we will get Vmax. Now from that Vmax we can calculate half Vmax, that is half of the maximum velocity. At half Vmax, whatever it is cutting over the graph, and from that cutting of graph we will get a value over the x-axis, that is substrate concentration. So substrate concentration which is over the x-axis, that particular substrate concentration at the point of half maximal velocity, that is called a Michaelis constant, or name is given, that is Km. Now that Km has a lots of importance that we will look. So Michaelis constant or the Km. So Km value is the substrate concentration at half maximal velocity. That definition you have remember of the Michaelis constant, that is substrate concentration at half maximal velocity. So what is Michaelis constant? It is simply a substrate concentration. 50% means half of the enzyme molecule is attached over the substrate. Km is independent of enzyme concentration. If you double the enzyme concentration, the Vmax, whether it is 50, 100 or 200, 50% of molecule are bound to the substrate at the particular substrate concentration, so percentage will remain the same. So that is importance of the Km value. So Km is called as signature of the enzyme also. It is constant for an glucose, fructose and galactose, but hexokinase have a fixed Km value for the glucose for a particular substrate or specific sub value, that is, so the smaller the tendency for the dissociation of the constant. So simple that enzyme affinity of the enzyme towards the substrate is inversely related to the dissociation constant, and so the smaller tendency for the dissociation of the complex, the greater value of Km, that is showing more affinity of the enzyme for the substrate. So if suppose tendency to attachment over the substrate enzyme, that is depending on the Km value. So which enzyme have a low Km value, that have a high affinity for the substrate. So enzyme with a low Km value, that is attached over the substrate, but enzyme with a high Km value will not attach over the substrate. So that is also important things of the Km value. This of Km value and substrate concentration into substrate concentration, max value, Km value for this enzyme activity, and we have substrate concentration, we can get velocity for that particular substrate and enzyme activity. Further, with the help of this calculation, it is interesting to know about the Km value. We are saying that Km, that is substrate concentration at half maximal velocity. Now that half maximal velocity that we are putting in this equation. So suppose that V0 we have kept its V0 as a Vmax by 2. So what happened? We are keeping Vmax by 2 at this V0. Now so that Vmax into substrate concentration, that is remain same, Km plus substrate. So Vmax both are cutted. Now what happened? Km plus substrate concentration, that is over one side, and 2 substrate concentration. So we are saying that Km plus substrate concentration is equal to 2 substrate concentration. So from that Km substrate is going over this side and it is minus from that 2 substrate concentration. So Km is remain as a single substrate concentration. Simple that is substrate concentration at half maximal value. So when using different substrate, suppose same enzyme is that, I have said that about the hexokinase. Hexokinase can work